Hello everyone! In this fluid dynamics and fluid mechanics tutorial, we provide a correct and intuitive definition and explanation of the fluid flow rate. Also, in this tutorial, we derive the famous equation for the flow rate that says that the flow rate is the product of the fluid velocity and the cross-section area through which the fluid passes. In our next tutorial, we will provide an intuitive and correct explanation of the continuity equation. Some of you might ask me the following question. Why do you create this lecture and this video tutorial when online we can find tons of material, lectures, and video tutorials on the fluid flow rate? Well, the main motivation for creating this lecture comes from the fact that online you will often find incorrect or only partially correct definitions of the fluid flow rate, or the definition is stated by using very complex mathematics such as double integrals and multivariable calculus. Consequently, most of the students do not obtain the correct and intuitive understanding of this important concept that is essential for the development of other definitions and concepts in fluid dynamics. In reality, with only the knowledge of the basic calculus, one can easily understand the concept of the volumetric fluid flow rate. But before I start with explanations, I need to mention the following. It took me a significant amount of time, energy, and planning to create this completely free video tutorial, as well as more than 500 free video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start with explanations. This figure shows a section of a cylindrical pipe. The fluid flows from left to right. The first thing that we need to observe over here and to identify is this cylindrical volume of fluid. As the fluid is flowing from left to right, this volume will move from left to right. And it will pass through this cross-section area that's represented by this dashed circle over here. Next, let us consider this figure. At the time instant t, the volume of fluid, that is, our cylindrical volume, enters the cross-section area represented by this dashed circle. However, at the time instant t plus delta t, the volume of fluid exits the cross-section area. That is, it takes delta t amount of time for the volume of fluid to pass through the cross-section area. That is, it takes delta t seconds for this cylindrical volume to pass through the cross-section area. Now we are ready to define the average fluid flow rate. The average volumetric fluid flow rate is the volume of the fluid that passes or flows through the cross-section area during the time interval delta t. Let us now mathematically formulate this definition. Let the volume of the fluid be denoted by delta V, and here it is. It's simply the volume of this cylinder. Then, let the cross-section area be denoted by A. Here it is, and here it is. Next, let the height of this cylinder be denoted by delta H. Then, we can say that the average volumetric fluid flow rate, denoted by Q, AVG, where AVG stands for average, is equal to delta V over delta T. And this is the mathematical statement of this definition. Let us now write this formula a little bit differently. From this figure over here, we can see that delta V is A times delta H. Consequently, we can write, instead of delta V in the numerator, A times delta H. And in the denominator, we have delta T. Next, let us write this equation like this. delta H over delta T multiplying A. On the other hand, the distance that any cross-section of this volume of fluid travels during the time interval delta T is delta H. For example, we can see over here that this top surface of our volume will travel the distance delta H. Similarly, any cross-section of our volume will travel the same distance delta H. And this distance will be traveled during the time interval of delta T. Now, what is delta H over delta T? Well, delta H over delta T is simply the average velocity of our fluid volume. That is, V average is delta H over delta T. If we substitute delta H by delta T in this equation with V average, we finally obtain that Q average is equal to V average multiplying A. That is, the average flow rate through this cross-section A is the product of the average velocity of the volume of fluid and the cross-section area A. And that's it. This is the first important formula that we derived in this video tutorial. This is the average flow rate. Next, let's define the instantaneous flow rate. The instantaneous flow rate, denoted by Q, is defined from the definition of the average flow rate when we let delta T to go to 0. That is, Q is limit value when delta T goes to 0, delta H over delta T multiplying A. Since A is a constant, this limit will act only on this term over here. Next, let us see what is the limit value when delta T goes to 0 of delta H over delta T. Obviously, this is a velocity. Actually, this is the instantaneous velocity of the fluid volume that passes through this cross-section A. And we can say that this is V, where V is the instantaneous velocity. If we now substitute back V from this equation in this equation, we will finally obtain the expression for the instantaneous flow rate. The instantaneous flow rate becomes Q is equal to V times A. And this is the classical formula for computing the flow rate. That is, whenever you see Q is equal to V times A, this is not actually the average flow rate, this is the instantaneous flow rate. The unit of the instantaneous flow rate is cubic meters per second, or divided by second. And this is the amount of volume that passes through a pipe in unit of time. That is, the instantaneous flow rate is defined as the product of the instantaneous velocity V of the volume of the fluid and the cross-section area A through which the fluid flows. We usually omit the word instantaneous and we refer to the instantaneous flow rate simply as the flow rate. Okay, that would be all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.